Hello and welcome back to Software Testing Studio. Today I'd like to give you a brief overview of a powerful load test tool called K6. So what is a K6 tool? It's a developer-centric, free open source load testing tool which is built for making performance testing a productive and enjoyable experience. Using the K6 tool, you'll be able to catch performance regression and problems earlier, allowing you to build resilient systems and robust applications. It allows you to test the performance of APIs, Microsoft's or microservices, and websites. It is optimized for minimal consumption of system resources. It's high performance tool designed for running tests with high load, spike, stress, soak tests in pre-production and QA environments. It provides a great primitive for testing, for performance testing automation, and you can run tests with a small amount of load and then continuously monitor the performance of your production environments. What is the K6 Manifesto? The first one is simple testing is better than no testing. Load testing should be goal-oriented, and load testing should be done in a pre-production environment. I'll discuss each of these key aspects of the manifesto in next section. So, simple testing is better than no testing. Load testing should mimic real-world users, clients as closely as possible, whether it's a distribution of requests to APIs, or the steps of a user moving through a purchase flow. But let's be pragmatic. The 80-20 rule states that you get 80% of the value from 20% of the work, and a couple of simple tests are vastly better than no test at all. Start with a simple, small, and make sure that you get something out of the testing first, then expand the test suite and add more complexity. The next manifesto is load testing should be goal-oriented. A prerequisite for successful load testing is having goals. Specifying performance goals is such an important part of load testing. Above what level is a response time acceptable? What is an acceptable request failure rate? It is also good practice to make sure that your load testing is functionally correct. Both the functionality and both performance and functional goals can be achieved or codified using threshold and checks, which are similar to asserts. With your goals defined, it is a straightforward task to achieve this, as your threshold will, on failure, cause the K6 to return a non-zero exit code. The last manifesto is load tests should be carried out in a pre-production environment. There must be a strict separation between production and pre-production environments. Load testing should occur in pre-production. Testing in pre-production is risky business. It is risking the interruption to business and should only be done if your processes are mature enough to support it. What are the key features of K6 tool? It consists of a CLI tool with developer-friendly APIs. It supports scripting in JavaScript with support for local and remote modules. It also has checks and thresholds for goal-oriented automation-friendly load testing. What K6 doesn't do, it does not run in a browser. As a result, K6 does not render web pages the same way as browsers do. This also means that libraries relying on browser API won't be compatible. By skipping the browser, the consumption of system resources are dramatically decreased, making the tool significantly more performant. It does not run Node.js. Node.js is a backend JavaScript routine environment that runs on the V8 machine and executes JavaScript outside the web browser. So K6 does not support that, or does not run in Node.js. Let's look now at the anatomy of tests in K6, of course. You first initialize the code, you set up the code, and then the main part is where you specify the virtual user's code and where you loop over for the duration of the test, and then you tear down the code. So you initialize the code, you import the rates, the counters, you export the constant options. This is where you specify the threshold virtual users. It's optional, this section. You export the function setup. So this is where you use this section if you want to create specific user that you use throughout the test. The main part that is compulsory, obligatory, is the export default function. And finally, you tear down. This is used to get rid of those users created earlier. Types of metrics. We have the counter, which is metric that cumulatively sums added values. Gauge, which is a metric that stores the minimum, maximum, last values added to it. Rate, a metric that tracks the percentage of added values that are non-zero. Trend, which is a metric that allows for calculating statistics on the added value, such as minimum, max, average, percentiles. Finally, integrating a K6 test with pipeline is essential. They can be easily added as another steps in the pipeline, picking up the load test scripts from version control so they can be executed. If the thresholds are crossed, then the K6 will exit with a non-zero exit status, causing the CI job to fail. However, note, for scenario load test, it is not recommended to run load test on every commit, but rather in the frequency of range, for instance, daily. However, for unit load test, where a single or only few API endpoints are being tested, running performance regression testing on every commit is appropriate. Let us now look at an example where we can show you how this works in action. So here I have a K6 script, and this is the section where we import all the libraries, the checks, the counters, rates that we're going to use. Here we specify the number of virtual users, duration, threshold, and this is the main section where we're gonna try to get to this website, and obviously we're gonna create 5 users for 10 seconds. We added a threshold because obviously we don't want to be just loading any site. We want to make sure that we are loading the right site, so we add what we call this is the checks or assertions. So making sure that on that page for header 2 there is a text, otherwise it will fail. So if we look at this website here, so for instance we want to go to this web page here and assert that this exists. Okay, otherwise it will fail. So let's run it and see what happens. As you can see, it's loading the virtual users. Here we go. It's saying we got errors. Let's see what I've done in the code. There shouldn't be any errors here because probably I did not save it previous occasion. So let's run it again because I want the test to pass now. Because that error previously says threshold have failed, so it's complaining that it can't find the assertion. Okay, here we go. That's passed. So status 200 means it found the web page. It has looped. It had created 5 virtual users. It's done the checks, and this is the main bit, which is the request duration. It's 100.24 milliseconds. So what I want to do here, let's simulate it failing. So in the assertion here, let's just add some, modify the script so it doesn't find it. Make sure I've saved it again. Let's run this. Yeah, so that's a fail. Yes, so obviously it has found, it returns status code 200, meaning they found the web page, but we have an error here, 517, and it's saying some thresholds have failed. Okay, so it has failed. So let's correct the threshold. so you can pass. And it has passed now. We have no errors whatsoever. So I'm running it now using the command line, but note that if you integrate it with in Azure pipelines, it will get the same errors, the same response. So that's it for now. This is a very brief session to give you an overview of K6 tool with an example to give you an idea of what it is. I hope you enjoyed this session, and if you have any comments or queries, please leave them in the comment section below, and I'll see you in the next lesson. Thank you.